Hello, my dear student. I'm Mr. Kitwala, a physics teacher from Educare TZ. And today we are going to proceed with our revision questions for the topic of light from Form 3. Now, today let us go and proceed with the question number 9. My dear student, as you see our question here, question number 9. Our question number 9 says that light is instant on air-water interface at an angle of 40 degrees, given that the refractive index of water is 1.33. Determine the angle of refraction of the light in the water. Now, as you see our question here, that from our question we have the the angle of instance between the air and the water. And also we have the refractive index of water, but we are supposed to find the the angle of refraction of the light in water. Now let us go and see our values which we have given from our question here. Now as we see here from our question that we have the angle of instance which we term it as the theta 1. The angle of instance equals to 40 degrees. And also we have the refractive index of air. Always the refractive index of air is approximately to 1. And also we have the refractive index of water, which we have given from our question here, which is equal to 1.33. And also from our question, we are supposed to find the angle of refraction. Now let us rate that the angle of refraction can be represented by theta 1 because the angle of instance is represented by theta 1. Now let us term the angle of refraction be theta 2. Now as we want to solve the question like this one, first of all, we are supposed to use the Snell's law. And as we know that the Snell's law gives us the ratio between the angle, the refractive index of air, it means over the refractive index of water equals to sine theta 1. It means that the angle of instance over the angle of refraction. Now, after there, let us go and substitute. Now, our formula is this one because this refractive index 1 is represented by this symbol, and also refractive index of water is represented by this symbol. But the angle of instance is represented by theta 1. Finally, the angle of refraction is represented by theta 2. Now, where this symbol represents as the refractive index of the two media. It means that one is the refractive index of air and the other is the refractive index of water. And the theta 1 are represented by the the angle of instance, and also theta 2 is the angle of refraction. Now, after there, we go and substitute our value which we have given from our question. Now, as you see here, my dear student, that the refractive index 1 is approximately with 1. Now, we have substituted 1 here times the sine theta 1. But theta 1 is the angle of instance equals to 40 degrees. Finally, we have the refractive index of water, which is equal to 1.33 times the sine theta 2. But the theta 2 is represented by the angle of refraction. And after there, we will go and solve for the sine theta, for the theta 2. It means the angle of refraction. Now, as you see here, that in order to get the theta 2, first of all, we have to divide by 1.33 both sides. And after dividing it, you can make theta 2 at the subject by taking sine inverse. It means multiply by sine inverse both sides. After dividing this one, you will get that the theta 2 equals to 29.2 degrees, and that is the angle of refraction. Now after there, this will be the end of our question number 9. Now you can conclude by saying that therefore the angle of refraction of the light in the water is approximately to 29.2 degrees, and this will be the final result for our question number 9. Now after there, let us go and see another question, which is the question number 10. Now my dear student, as you see our revision exercise question number 10 here, that our question said that a stone is lying at the bottom of a pool of water 3 meters deep. What will be the stone's depth as seen by the observer standing near the pool? Use the refractive index of water equals to 1.3. As I told you, my dear student, that when you meet with the question like this one, first of all, you have to read your question and make sure you have understanding the need of your question. Now, let us repeat again so that we can understand very clear that we have a stone, and that stone is lying at the bottom of a pool of water. Kwamba kuna jiwe ambalo lile jiwe limedumbukizwa kwenye bwawa, kwamba lipo kwenye height ya 3 mita kwenda chini, lakini akakwambia kwamba je, ile stone depth as seen by an observer, kwamba yule observer ambaye alikuwa amesimama, je, aliweza kuliona lile jiwe katika height ya ngapi? As we know that this is the question of the refractive index. Now, in order to solve the question like this one, first of all, we are supposed to understand our question. And here, as we see that we have the stone, and that stone is placed on the pool at the height of 3 meters deep. It means that we have given the apparent, the real depth. It means the actual depth of a stone when it is placed on the pool. And also, we are supposed to find the apparent depth, the depth whereby the observer standing and observe which depth the stone can be seen, can be appeared. Now, but we have the refractive index of water. First of all, let us go and summarize our given values from our question here. As we see that from our question we have the actual depth, and at another time we call that this is the real depth, the actual depth, which is equal to 3 meters. It means that the height where the stone were placed on the pool equals to 3 meters. And also from our question we have the refractive index of water, which is equal to 1.30. But we are supposed to find the apparent depth of the stone, kwamba lile jiwe liliweza kuonekana katika depth ya ngapi baada ya kuliplace katika height ya 3 meter deep kwenda chini. Je, lilionekana katika height ya ngapi? It means kwamba the apparent depth. Now, first of all, my dear student, we have to observe our given values and the unknown values, and let us think the formula that gives the relationship between the value that we have given from our question and also the unknown values. And because our formula needs us the relationship between the real depth, apparent depth, and the refractive index. Now we can recall that refractive index can be obtained by taking the actual depth over the apparent depth, or at the other time you can say that refractive index is equal to real depth over the actual depth. But from our question we are supposed to find the apparent depth. Now, how can we find the apparent depth? Now, first of all, as you see here, my dear student, we are supposed to make the subject the apparent depth. Take your formula and make the subject the apparent depth. And after making it the subject, you will get that the apparent depth is equal to actual depth over the refractive index of water. Now, after there, you can substitute kwamba using the given formula. You have to apply your formula here and substitute your data. And after there, you have to solve and get your unknown values. Now, as you see here, my dear student, we have substituted that the place where there is the real depth or the actual depth, we have written that is equal to 3 meter, and also the place where there is the refractive index, we have substituted which is equal to 1.3. Now, after there, you can divide, and after dividing it, you can get that the apparent depth of the stone is equal to 2.31 meter. Now, after there, you can conclude, my dear student, by saying that therefore, the observer standing near the pool will see the stone at the apparent depth of 2.31 meter, and this will be the answer of the question number 10. So you have to ensure that after getting your solution, my dear student, first of all, you have to conclude and put your psi unit, because without writing your psi unit, it means you will miss your marks. Now, it is very important to write your psi unit after getting the unknown values or the solution that you were supposed to find. Now, after here, let us go and see another question here, which is the question number 11. As you see here, my dear student. Now, our question number 11, let us look together and read this question, and after there, we will think the formula that we can apply so that to obtain the unknown value. Now, as you see here, our question that the speed of light in water and in air is 2.8 exponent 80 meter per second. That we have the speed of light in water, and also we have the speed of light in air, which is equal to 3.0 exponent 80 meter per second respectively. Now, our question needs us to determine the refractive index from the air to water, and also Roman B, we are supposed to find the ray of light traveling from the air to water of instant at the surface of water at the angle of 30 degree. Calculate the angle of refraction in the water. Kwamba kama nilivyowaambia wanafunzi wangu kwamba unapokutana na maswali kama haya, cha kwanza unapaswa ulisome swali lako, na baada ya kulisoma swali lako, andika data ulizopewa kwenye swali lako, na baada ya kuandika utaweza kutambua kwamba ni kitu gani ambacho hujapewa. Now, after writing it, you have to think the formula that you can apply so as to get the unknown value or the solution. Now, as you see here from our question, that our question in Roman A need us to find the refractive index. Now, my dear student, how can you get the refractive index? First of all, let us look for the data that we have given from our solution here, from our question here. That as you see here, our question, that from our question we have the speed of light in water, and also we have the speed of light in air, and we are supposed to find the refractive index from water to air, or from air to water. Now, which formula gives us the relationship between the speed of light in the air and the speed of light in water? You can get that refractive index on the other term can be obtained by taking the speed of light in air, you divide it by the speed of light in water. Now, as you see here, my dear student, that in order to get the refractive index is equal to the speed of light in the air if you divide it by the speed of light in water. Now, after there, you will substitute your values that you have given from your question. As you see, my dear student, we have substituted that the place where there is the speed of light in air, we have written as 3 exponent 80 meter per second. You divide by the speed of light in water, which is equal to 2.80 exponent 80 meters per second. Now, as you see here, that at the top and at down we have the meter per second. Now you can cancel it out and you will get the refractive index equals to 1.07. Now, as we know that the refractive index always does not involve the psi unit. Now you can write that the refractive index equals to 1.07, and after there you will conclude by saying that therefore the refractive index from air to water is approximately to 1.07. This will be the refractive index from air up to water. Now, after there, let us go and see the question Roman B. Now, as you see here, that our question Roman A or Roman B need us to calculate the angle of refraction in the water. First of all, you have to identify the value that you have given from your question. As you see that in Roman B, that we have the angle of instance. If we have the angle of instance, but we are supposed to find the angle of refraction. The formula that we can use, first of all, we have to record the Snell's law. As you see here on our question, that on our answer, that we can use the Snell's law to find the angle of refraction. And as we know that how the Snell's law said, our Snell's law give us the ratio between the refractive index, two refractive index, and the angle, it means the angle of instance and also the angle of refraction. That the refractive index in air times the sine of the angle of instance equals to the refractive index of water times the sine of the angle of refraction. And after there you will substitute, but since the refractive index of air is approximately to 1, this is always constant, kwamba inakuwa inakaribia ile refractive index ya air wage inakuwa inakaribia to 1. Kwa kama inakuwa ni approximately to 1, now we can substitute that the place where there is the refractive index of air, you can substitute equals to 1. But the refractive index of water we have obtained on Roman A. Now you can go and substitute here. Now after substituting that, you will get that 1 times sine of angle of instance, which is 30 degree. It means you will get the 30 degree equals to the refractive index of water equals to 1.07 times the sine of angle of refraction. And after there, my dear student, you will divide by 1.07 both sides. As you see that you can take 1.07 throughout, and after dividing it, the purpose of dividing is to make the sine theta, the sine of refractive of the angle of refraction as the subject. Now, as you can see here, after dividing it, you will get that sine 30 degree over 1.07, and after there take your calculator and read the sine of 30 degree, or you can use the special angle, that the sine of 30 degree always is equal to a half. Now after getting a half, you will get that you will take a half divided by 1.07, you can get the sine of angle of refraction is equal to 0.442. Now after there, you can say that after getting this value, now you can multiply by sine inverse throughout. Now if you take your calculator and multiply by sine inverse both sides, it means the sine at the left side will be cancelled out, and after there the sine will be erupted on the right side. Now after there you will go and read the sine inverse of 0.442, you will get that equals to 26.2 degree, and after there you will get the value, the angle of refraction. Now after there you will conclude by saying that the angle of refraction in water is approximately to 26 degree, because this is an angle. Now you are supposed to put the psi unit of an angle, which is always degree. You can put that which is equal to 26.2 degree. And after there, my dear student, this will be the end of our question number 11 and will be the end of our session. Now, thank you for following our Educare Media. I would like to invite you again for another session. God bless you.
Purchase your tracks today.